Hello friends, my name is Samad Khattuar. First of all, I want to thank Professor Bainwar sir for giving us opportunity to show our talent, creativity and our knowledge. So, as we know, CNC is a very application level subject, and it helps us, and the subject helps us to know various operations and working principles of various CNC machines. And before starting the video, I want to tell that the video will be slightly longer because I am explaining two subtopics of our fourth unit, that is G codes and M codes of the VMC machine, and the comparison between the Peck drilling cycle and the normal drilling cycle. For that, we need to know the basic G codes and M codes. So we will start with the M codes.
The first one is M00, that means program stop, that is used to end a program. Then second one is M01, that is conditional program stop, which we generally use when we have to inspect the workpiece in between the operation is being performed. Third one is M02, that is end of program, which is used in the Siemens control panel for ending a program. They are codes like this M02 which are especially used in a special type of control panel. The fourth one is M03, that means spindle on and rotate clockwise. And fifth one is M04, which is used for rotating the spindle in counterclockwise direction. After that, M05 is used for spindle stop. The seventh is M06, which is used for tool change, and address code T is used with it, that represents the tool number. Then moving on to the M07, high pressure coolant on, and M08 is normal pressure coolant on. Now M09, that is used for coolant stop, and the last one is M30, which is used to stop the program and rewind the program from the first. First is G00, rapid positioning. By using this, the bed of the VMC moves with its maximum speed. Second is G01, linear interpolation. Interpolation means movement. It is used for linear movement of the bed. Third is G02, circular interpolation clockwise. G03, circular interpolation counterclockwise. It is used for the circular movement of the bed, and by using this, we can make various circular slots on workpiece and can give workpiece borders the fillet in clockwise or in anti-clockwise or counterclockwise direction. Fifth is G04, that means dwell. This code is used to hold the tool in a particular place for given time, and an address code P is used with it, which represents the time. Sixth is G20, which is used for input of values in inches, and G21 is used for input of values in mm or matrix. G28 means zero return or return to reference position. It is used to move the bed of the machine tool to the reference position or the zero position. Ninth, G40 means cutter compensation cancel, G41 means cutter compensation left, and G42 means cutter compensation right. Now 12th, G43 means tool length compensation in positive direction, which is mostly used. G44 means tool length compensation in negative direction, which is very rarely used. G49 means tool length compensation cancel. After starting the tool length compensation, we have to close the command by using this code. So G54 to G59 are used as workpiece offsets. These are used to set and save the workpiece offset of different workpieces clamped to the bed. G74 means left hand taping cycle or counter taping cycle. G80 means cane cycle cancel. Now 18th is G81, which means normal drilling cycle or spot boring cycle. G83 means peg drilling cycle, which we are going to use. G84 taping cycle or right hand taping cycle. G90 means absolute command mode. G91 means incremental command mode. G94 feed per minute. G95 feed per revolution. G98 return to initial level, and G99 return to reference level. So we start the comparison between the normal drilling operation program and the peg drilling cycle program. Now see the length of both these two programs. As you can see, the length of the normal drilling is more than that of the length of the peg drilling cycle program. So this is the first advantage of the peg drilling cycle, that it has shorter length of program for the same operation. Another advantage is that while performing the operation practically, the finishing of the holes drilled by the peg drilling cycle is better than that of the normal drilling cycle. So that's the second advantage. Now we will understand the diagram first. This is the workpiece in which we have to drill 5 holes in it. The workpiece is of dimensions 100 mm by 100 mm, and this is the point which is to be taken offset. Now these 4 holes are of diameter 10 mm, and this center hole is of diameter 12 mm. Now let's start the normal drilling cycle operation. This is the program of that. G00, G91, G28, Z0.0 means return of Z axis or tool to its 0 position. Then after that, G00, G91, G28, X0.0, Y0.0. This is the return of X and Y axis to its 0 position. These two lines are very important at the starting of the program. So M06 T1, that is tool change, and the T1 means the tool number 1. This is the work offset saved at G54. Now G00, G90, G43, H01, Z60. This is the tool offset for tool number 1, and Z60 means the tool is kept 60 mm above the workpiece. So it is the tool offset. Now G00, G90, G01, X20.0, Y20.0, we are giving this address of this first hole. Next is M03 S700. We are rotating the spindle in clockwise direction at spindle speed 700 rpm. Now next is M08, that is coolant on. So G01 Z5.0 F800, we are keeping tool 5 mm above the workpiece. As we see in the diagram, the height of the workpiece is 20 mm. So we have to insert the drill bit more than 20 mm for the proper finishing of the holes drilled. So we took minus 25 mm with the feed of 50. So here we took Z minus 25 and feed 50. Then after that, the return to reference position. After that, the X80 and Y80 is the address for the second hole as shown in the figure. Then minus 25 means insert the drill bit in 25 mm inside the workpiece, and Z5 means return to reference level. Similarly, the third and the fourth hole is also located by giving the address of that holes, and by using Z minus 25 we insert the drill bit 25 mm inside the workpiece, and then again bring that workpiece tool to reference point. Then by M06 and M05 and M09 the spindle is stopped and coolant is stopped. Then M06 T2,
Here tool is changed and T2 means tool number 2. Here diameter of this drill bit is 12 mm. G00, G90, G54, X0.0, Y0.0. Again giving work offset, and then G00, G90, G43, H02, Z60. Here we are giving tool offset by using H02, that is height of the tool 2. Here, after starting the spindle and coolant by X50 and Y50, the address of the center hole is given. And then by Z minus 25, we are inserting the drill bit inside by 25, and Z5 means return to reference level. M05, M09 means coolant off, spindle off. Then G00, G91, G28, Z0.0, return of the Z axis to its 0 position, and then G00, G91, G28, X0.0, Y0.0, then return of X and Y axis, both the axis is returned to its 0 position, and then M30 means program stop and rewind from the first. Now we will start the peg drilling cycle. So this part is same for both, but only difference is in this line. We are using G99 return to reference level, G83 peg drilling cycle, and address of first hole. R5 means return to reference level, and Q means dwell time for 4 seconds, and then address and then peg cycle for the center hole, and the rest is same for both the programs. So I expect that you would have understood the difference between both the programs, and if you have any queries, then just contact me. And at the last, I want to request you all that stay at home, stay healthy, and let's unite and fight against corona. Thank you.